this video, we'll take up examination style question on kinematics, application with vectors, where we will see how to relate displacement, velocity, and acceleration. We will understand the column operation, interpret the results to solve this question. You may join my classes, gain confidence, connect learnings, get ready for future. Gift of education for success is the bottom line. Let's enjoy the session with Emmy. Hi, Emmy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. Very good. So today, what do you want to learn?
I was hoping to continue with like mechanics, but kind of a more broad like perspective and overview of it, like it would be kind of in the exam, diving into like a variety of topics. Still obviously focused on like forces, moments, inclined plane vectors, but yeah, just seeing how we can like adapt and like approach each question.
That's very good. So
a particle P moves with acceleration 4I minus 5J. At the time t equals 0, P is moving with a velocity of minus 2I plus 2J. Part A, find the velocity of P at time 2 seconds.
Okay, so let's write down the equations given to us. A particle moves with an acceleration A of 4I minus 5J, right? So these are unit vectors.
Yep.
Meters per second square. Okay, and the velocity is given to us as minus 2I plus 2J. Find the position P at time T. So we have to, you know, the equations, Suva equations, right? We need to find the velocity of P at time T equals to 2 seconds. V equals to U plus AT, you can say, right?
Yeah.
Velocity, or we can use your Suva equations. So we have
so we have acceleration.
We have an acceleration, right? So since we have an acceleration, initial and final velocities will be different, right?
Yeah.
So V equals to U plus AT.
Wait, so just a quick question. You know when it says at time t equals 0, P is moving with velocity, is that the U in this Suva equation?
Yeah, so this becomes the U, right? So I wrote V, let me write V0, right? So V0 is our initial velocity. So this is at t equals to 0, right? So I'm writing t equals to 0 is V0. So in that case, I now know acceleration and I know the time. So the velocity at 2 seconds, let me write this as V2, velocity at 2 seconds will be equals to the initial velocity, which is given to us, right? Plus acceleration, which is also given to us, times t, which is 2, right? So now we'll do this vector addition. So we have initial velocity of minus 2I plus 2J. So it's good to write like this. Do you use this convention? Minus
column vectors.
Yeah, this is better, right? So plus 2 times 2 is a scalar multiple of acceleration, 4 and minus 5. Is it clear to you?
Yeah.
So you can now write, this is 4 times 2, 8. 8 minus 2 is 6, right?
Yeah.
Minus 2 plus 8. Let me write this. And then we have 2.
2 minus 10.
And so we have this as 6 and minus 8. So you can write the velocity at time t as 6I minus 8J. Is that clear to you?
Yeah.
So that becomes the solution of this particular question for A. Yeah. Read.
At time t equals 0, P passes through the origin O.
Yeah.
At time t equals t seconds, where capital T is greater than 0, the particle P passes through the point A. The position vector of A is lambda I minus 4.5J, which is relative to O, where lambda is a constant. Find the value of T.
Correct. So let's try to visualize the situation. So what we have
is, always draw a diagram.
Let's say this is origin. So it says At t equals to 0, p passes through the origin, so it's there at the origin. At t equals to t seconds, where t is greater than 0, particle p passes through a. So let's say this is a, right? And this is the time t, capital T.
So is velocity on the y-axis?
No, we'll go along with the body, right? So we're just saying the position now, right?
Okay.
So we'll say the position vector A is, so now we know the position vector, you understand?
Yeah.
So displacement is known to us now. Position vector gives you the displacement, because now the position vector is very important to understand here, that the position vector gives you displacement.
Wait, how come it gives displacement? Because it's
origin,
like,
take away from origin, right?
oh, yeah. Right.
Let me write displacement from origin. Is that clear?
Yeah.
So the position vector is given. That means you now know the displacement, right? In terms of lambda I plus minus 4ij. And you need to find the value of t, correct? And hence find the value of lambda. So that is what we are given, right?
Yeah.
So now you know the displacement. You can use this SUVA formula to find, acceleration, initial velocity, right? You know the final velocity. So with time being capital T, so S equals to ut plus half at square can work for you, correct?
Yeah.
S
But so just a quick,
yes.
Sorry, just a quick thing. When we do these calculations, we shouldn't like convert like acceleration and find like magnitude of it and then start solving SUVAT. We have to do it in terms of vectors, right? Or would our answer change if we find magnitude of everything, like velocity, the acceleration, the initial?
You need not do. You can work with the vectors. You get the idea, because we are using scalar multiples. We are using scalar multiples, just as we did earlier. Time times a, 2 times a. You get the idea? Scalar multiple. Now, when you have two vectors involved, when you're multiplying, correct?
Yeah.
In that case, it is a different story. So it is good to do it separately as a triangular forces and then figure out the resultant kind of thing, what you are talking about.
I see. Okay.
But in this case, I think it's a scalar multiple. So S equals to ut plus half a t square, correct? Time is capital T for you. You get the idea? And displacement is lambda I minus 4.5j. So you can write this as displacement is lambda and minus 4.5. Is that clear to you?
Yeah.
As far as u is concerned, it is given to us as minus 2 plus 2, right?
So when you write it in this fashion, you don't need to be writing I and j because it's already like shown. Yeah.
Yes.
Okay.
That
makes it easier.
Yes. It's easier. That's why. So u and time t is capital T plus half a is given to us as 4
minus 5
and t
times t squared.
So that becomes one of your equations. There are two unknowns in this particular equation. Is that clear to you?
Lambda and t.
Lambda and t. So
do we need to find another equation so we can like
find the value of lambda? Yeah. Find the value of t. Now, since we know the j particle, right? We know the lower part, which is minus 4.5. So there is an equation within this equation, right? So let me just equate part, which is j component. We know 4.5. Do you see this portion?
Minus 4.5.
So that gives you that. Let me rewrite here. Minus 4.5 is basically equal to 2t
minus
plus
10.
Yeah, minus, because I'll multiply this. Minus 5 over 2, right? Because you're multiplying by half. T square. Is that clear to you?
Yeah.
So when you open this, now you multiply by 2, so you get minus 9 equals to 4t minus 5t square. Is that clear to you?
Yeah, I nearly tripped up because
5.
it's timesing by a half, but it looks like it's another vector. So I thought it was just by 2. So that was really close. I was just about to do like 1 times 4, like it nearly threw me.
Oh,
So it's the whole thing.
I drew this orange line, so it kind of confused you. It's okay.
Oh,
So minus
yeah, okay, that's
4t, right? Minus 9 equals to 0. So we have this quadratic equation from where you can find the value of t. 4 times 9 is 45, right? So you could factor, or you could just use quadratic
multiply
equation.
across.
Does it make sense to you?
Can you just quickly maybe cheat and use a calculator?
Use calculator, right? So we have t as equals to 4 plus or
9
minus
over 5.
16 b square minus 4ac. So 4 times 5 times minus 9 is okay.
Yeah.
Or 2 times
2a, 2
5.
times 5. So I got 2 values. So it was 9 over 5.
Okay, you already calculated. So 9 over 5.
Yeah, just to save you time. And minus 1, but you can't have negative time. So
right. So t equals to 9 over 5. Does it make sense to you?
yeah.
So we found the value of t using j component, right? And now we can find the value of lambda using the I component, right? So we have
that's
this
a nice question.
Yeah, beautiful question. So we have lambda equals to minus 2t, and t we know plus half times 4, which is 2t squared. Is that clear to you? So plug in t as 9 by 5. So minus 2, 9 by 5 plus 2 times 9 by 5 square, whole square. Yes.
Calculator. So minus 8, minus 3.6 times 2. 2.88.
So that becomes the value of lambda. Do you see how we figured this out? And of course, t is in seconds, so it's all done, right? So you can actually calculate this about 10 and find this answer. So 20 times 9, so 16 plus 20 times 9, 180. Okay. Is that clear?
Yeah, very clear. So initially, when I see questions like this, especially with vectors, it can be seem like quite a lot. But if we kind of go step by step and just, I guess the main point was knowing like the position vector is a displacement from the origin, because they're telling you about A and like the lender moving, and then knowing you have to use suvat, and then kind of going from there. But yeah, I think when I would have approached it, I would have started like doing magnitudes, because I don't know, but working with vectors is just not as familiar as using like whole numbers or something. But in this case, the way you like laid it out and everything, it has to be done, I think, like in this format, because it is vectors and it does need to be approached like this to get the right answer. So I would save a lot of time. Perfect.
So Abby, let's understand this part of vectors. Vectors originated only to explain physics. You get the idea. Well, the whole mathematics is developed to model the real life situations. And in physics, we came up with 2 very important things. One is like you do work done, and you say work done is a scalar quantity. It does not have a direction, right? And then torque is also a product, but it is a vector quantity kind of. I mean, that was a philosophy, because there is a direction. When you rotate something, it goes up or down, right? So that's in a different plane altogether. Now, how do we explain this part mathematically was a challenge, right? So I see vectors as a problem solver, or to model this particular situation. So vectors were introduced so that they could take care of the products of different kinds. One product, force and distance, which gives you work done, right? Which is a scalar quantity, and force times, which they call cross product in vectors, r, right? Where applied at r distance away gives you torque, which is vector quantity. So we have dot product and we have cross product in vectors, correct?
Right. And so it combines the 2 together.
Combines the 2. In this chapter of kinematics, when you're studying, in that case, you are doing only scalar multiple. Do you see that? So this is a different product.
Yeah.
This is a scalar multiple. So we are using time as a scalar quantity, which is multiplying with the vector quantities, and then you are adding or subtracting to get the result. So
Right.
we have to understand in this fashion so that we could actually solve these questions effectively. Does make
Right.
sense?
Yeah, very clear. It's nice to know that. Yeah, I didn't realize the importance of vectors, but yeah, how it merges the two like kind of fields together and makes it easier to model.
Very.
Like, yeah. Okay.
Good. So, any other questions? So, Amy, we did deal with 2 questions today. What did you learn in these questions? Can you tell me, please?
Yeah, so first, I guess the one we've just done, since it's kind of fresh in my mind,
Right.
was with the vectors question. So we had the position vector and knowing it's, finding the displacement from that. And initially when we started, trying to like depict the question, make it like into smaller pictures. So we kind of sketched a graph knowing like what t is, and then I guess in terms of solving it, we just kind of use SUVAT and substituting in our column vectors and solving like methodically. With the last question, we saw, we solved the 4 marker in terms of finding t just using the j component, and then with the next part, it was just using the I component solely. We had 2, variables that weren't which didn't have values for. So we formed an equation, and then usually like most students at that point will be like, okay, we're stuck now, because how can we solve this if there's 2 variables that we don't know? We can't isolate one. But it's about looking, especially with vectors, that's why you write it in the column form. You can see the equations within that equation. So it's really important. And then the other question, so I just have to look back. Oh yeah, was the inclined plane one. So this is really critical. Like it's literally like the topic that I've like been practicing a lot now. Forces on inclined plane. So just knowing that your reaction is perpendicular to the plane that you're on. We talked about mu r being a frictional force, but the main thing that I got from there was so let's say you have a larger mass that is really heavy and is on the same plane, and the like alpha is still 3/4 or it's still the same, the mu or friction that would not like change, or it wouldn't affect the motion of it. It will still be stationary and rest, because if it's a heavier object, it means the friction will increase by that same amount that the weight did. So the ratio is the same, so therefore it's not going to move any different. So that's a major thing to keep in mind. So those are the key points. Yeah,
good job. So that was excellent recap of our learnings today. So let's close the chapter here and take up new questions in the next class. Okay,
perfect. Thank you so much, sir. Thank you for your help.